Hello and welcome to the 27th module of Mastering Engineering Drawing, Foundations to Expertise. In this tutorial, we will delve into transformation projection by exploring the 3D to 3D copy isometric view exercise 1. Previously, we explored the construction of isometric views of various solids. From prisms and cylinders to cones, pyramids, and frustums, we learned how to accurately depict these shapes in a 3D space using isometric projection techniques. This foundational knowledge prepares us to tackle more complex transformation projections. Now, let's apply these skills to transformation projections, starting with exercise 1. In this module, this exercise introduces the process of replicating complex 3D shapes in isometric projection, building a solid foundation for more advanced tasks. With this understanding, let's move on to the key rules. 1. 3-path rule. Through each vertex, only 3 paths pass, each initially parallel to the isometric axes x, y, and z. 2. Path replacement rule. If a vertex lies on a sloped or curved surface, one axis parallel path is replaced by a surface parallel path, straight for sloped surfaces and curved for curved surfaces. 3. Path formation rule. Sloped paths are formed by locating and joining the end vertices, while curved paths are drawn as isometric circular arcs in the appropriate plane. With these fundamental principles in mind, let's begin. Copy isometric view, exercise 1. This is the 3D object we will replicate in our drawing. Observe its structure, features, and dimensions carefully. To begin, we will first identify all the vertices and then randomly annotate them, which will guide us through the step-by-step construction process in the isometric plane. Start at the origin, labeled as O. From this point, draw 3 lines parallel to the x, y, and z axes to define the isometric plane. Now, mark points A, B, and C at their respective distances from point O, as per the given dimensions. Next, focus on the open ends A, B, and C to complete the framework. At point A, draw the remaining parallel lines. Mark point E at a distance of 50 mm from A. At point C, draw the remaining parallel lines. Mark point D at a distance of 12 mm from C. Join points B and D. Join points B and E, which define the endpoints of the slope line. At point E, draw the remaining parallel line. At point D, draw the remaining parallel line. The intersection obtained is point F. This completes the basic framework. We will now work on the 2 cutout portions followed by the built-up portion. With the framework in place, let's move on to creating the first cutout portion. First, mark points G and H on the line OA at their respective distances from O and A. At points G and H, draw the remaining parallel lines. The intersections obtained are points I and J. At points I and J, draw the remaining parallel lines. Mark points K and L at a distance of 12 mm from I and J, respectively. Join points K and L. At point K, draw the remaining parallel line. The intersection obtained is point M. At point M, draw the remaining parallel line. Now that the first cutout is complete, let's proceed to the second cutout portion. Mark points P and Q on the line EF at their respective distances from E and F. At points P and Q, draw the remaining parallel lines. Mark point R at a distance of 12 mm from Q. At point R, draw the remaining parallel lines. The intersection obtained is point S. At point S, draw the remaining parallel line. The intersection obtained is point T. With the cutout portions finalized, we will now focus on constructing the built-up portion. Mark points U and V at their specified positions and join them. At points U and V, draw the remaining parallel lines. Mark points W and X at a distance of 16 mm from U and V respectively. Join points W and X. At points W and X, draw the remaining parallel line. The intersections obtained are points Y and Z. Join points Y and Z. Alright, with all the construction lines completed, the solid block has taken shape. Carefully darken only the visible edges to finalize the isometric view. This concludes the module. Before we wrap up, let's explore a few similar 3D isometric views. By practicing this exercise, you will find it much easier to draw these figures and shapes on your own. Up next, we will continue with our transformation projection exercises by taking on the second challenge. This exercise will deepen your understanding of 3D projections as we focus on more complex shapes and their isometric views. Thanks for watching, keep progressing through the series and stay tuned for more.